All right, cool. Hi, everybody. Welcome to this talk. Glad you could make it. It's the last talk of today. I'm aware of that and trying to make this worthwhile for you. A couple of words about myself. My name's Flo. I got into bad company about 15 years ago and started building online shops for a couple of companies as lead developer, architect, engineer, whatever. And during that phase, we developed a couple of front ends, back ends, etc. And I want to talk about what I learned during that phase. Right now, I work for a company that's called eTribes. It's a consultancy, and you might ask yourself, why does a consultancy have developers? eTribes is an end-to-end agency, they're called, or consultancy. So we do the consulting work, and then we implement a software solution for our clients. So this is why we also have tech capacities, of course. The topic of this talk is about e-commerce frontends. Doesn't have to be necessarily e-commerce, but we focus on that a little bit. And I want to walk you through some ideas that I had about how you should be building these front ends in the front ends for shops. And in order, of course, to understand what we want to do, is quite nice to have a look back and see what we did in the past. But before we start, I want to get to something to what does composable actually mean, because it's quite a buzzword. You got this Mach architecture with microservices and it's composable and everything. But what does that mean even? And my understanding of the whole thing would be that you have a shop on the right-hand side, and it calls a series of APIs to do e-commerce stuff. So load a cart, load a customer, or load products from a search engine, or it speaks to a recommendation engine to get product recommendations, or a login system. And what has changed, in my opinion, during the last couple of years is that the front ends are much more stateful. So you have personalization, and the user should see exactly his products and should see his preferences, etc. So it's much more catered to what the user is expecting to see and what is relevant to him than it was in the past. And fast, okay, that's something that had to be in the past too, but still, of course, it's a requirement. You want extra snappy pages that are really fast to load and show a really great user experience. Now, walking down memory lane a little bit, when I was at About You, roughly 10 years ago, the whole setup looked like this. So you had this backend development team, which was a PHP team. It had its own database. We also were calling internal APIs, such as the search API. So there were services even back then. And then this PHP application would be taking the data, stuff it into some sort of templating languages, and then HTML came out, was shipped to the user. And then there was another team, and this which was the front-end team. And the job of the front-end team was to take the rendered HTML on the page and inject itself in different places in the HTML and do its magic there. So the front end the framework we used for that was called Marionette and Backbone. We were clever enough not to use jQuery back then, which was like a big thing at the time. But still, it was quite ugly because the front end had to figure out which URL am I on, is it a category page, which elements am I expecting to find there, and then it would sort of inject itself into these elements and work with it. A couple of downsides in this hybrid approach. I mean, it's quite obvious. You still get full reloads on every page, so the front-end application loses the whole state, and you start from scratch, which sucks, of course, and you get the white page of unstyled content and all of that. Also, you would be having then duplicates in templates. So the server would have fragments of HTML to generate, and the front end would have those. And any change you would have to do in two places, which sucks. And also they were fragile because sometimes the backend team shifts around the HTML and then the front end breaks because it doesn't find the expected URL structures there. And also the UX was bad. White flashes of content, but also that sometimes the component would show on the screen and then it would go away and then it would re-render again because then the front end kicked in. It sucked. It was really terrible. And then at the time, React appeared, and we were one of the first large companies to use it, I guess. I think it was 004 at the time. And the ideas behind it were really brilliant. It was like, yeah, this is cool. Because then it would mean the backend team only gives you APIs. It serves the data via APIs, and the front-end team lives in the browser, and it renders what should be on that page. So the front-end calls this API, says, hey, give me the data, and then it stuffs it into templates, this JSX in our case with React, and would render that on screen. And if the user clicks on something, the front end kicks in and sees, oh, this is a new page, I gotta call this API again. and render it again. Sounds brilliant. Super idea. Great. Down the road, it turned out it's actually not so cool. It's actually quite problematic. The first thing, and this is something nobody really ever thought about, is that this now means your application is now running on a distributed system, because your front-end code now runs on a shitty mobile device with a weird browser on it and tons of extensions and bugs and whatnot on it. So you have no more control over the runtime of your application. And this is really problematic. And if you're doing front-end development, you know this. You get these errors in from Sentry or whatever, and you have no freaking idea how that got to be, because the environment the stuff runs on is so diverse and so fragmented that you have really a hard time keeping track of when things go wrong. Obviously, also, you have a white page initially, so this is something that SEO really hates. And then also one thing that's also turning out quite problematic is that you had to expose more data through the API than before. So if you think about it, HTML is actually quite lean in terms of the overhead. So essentially in HTML, you have what you show in the code. But with APIs, sometimes you load shit tons of data, and then you only show a fragment of it in the fraction of it in the front end. And also one thing, and this is something that bit us quite hard, is the state handling. So you might be still aware of Redux, RxJS, whatever they're called, like these state handling frameworks in the browser that would say, oh, you first got to call this API, load the user data, take this data, call another API. So it was like a stream of calls of APIs. And this was really something that was hard to get. Okay, now let's jump 10 years in the future, which is now. And this is how you would build these applications today. So quite a number of things have changed. Looking at it with this composable approach, you stop having backend developers really, because you're going to have commerce tools, you're going to have service providers that do this kind of thing for you. So a lot of the need for real backend development goes away. The front-end team, or you could also say the full stack team, not really sure about that. If you're working with this application like NextJS or Nuxt or whatever they're all called, they all work rather similar. How they work these days is that in the first layer, you have a backend for front-end API. In Next.js, this would be this get server-side props thingy, where you say, hey, I want to load data, and this BFF calls the backend systems, loads the data, gives them to the router, and then you have the server-side rendering of your React application in the server-side rendering part, and then you throw everything over to the front end. Plus, you have to freeze the state of your application from the server and also send that to the front end. The front end needs to load the HTML, it needs to load the JavaScript, it needs to load the state, needs to rehydrate the state, and then you get a single page app. And from there on, it works exactly like previously with the single page app, so it happens in the browser. It's just that API calls now go to the backend for front end again when you navigate a page. That's sort of the thing you do these days. Couple of downsides with this, and they're actually quite grave. So first of all, React was never intended to be a server-side rendering framework. It was intended to run in the browser. It has all these hooks and use effects and event bubbling and automatic re-rendering if the props changes and all that stuff. This is all something you don't need on a server. It doesn't matter. The server just takes data, renders it, spits out HTML. So you have a lot of overhead when it comes to rendering on the server. Also, one thing that is quite tricky is your application runs twice. It runs once on the server, then you ship it to the user via the wire, and then it runs on the client again. So you need to send a lot of JavaScript to the client. And if you think about it, if you have like a megabyte of JavaScript on a shitty mobile device, it simply will take a time to just process all of it. It's not a slow process. And also one thing is the state hydration I was talking about. This is also a complicated part, and it can be really tricky if stuff goes wrong. So, for example, these CSS and JS frameworks are quite notorious for breaking on the server because you're freezing the state and sending them to the client, and then stuff goes wrong. So it's tricky. And the current development, and this is something that's quite recent, I would say, is that all of these modern frameworks like Next.js 13, they have a lot of code in place for bundle splitting. So they break down your JavaScript in chunks and only send relevant chunks to the browser. But of course, nobody understands how that works under the hood because it's really complicated. You have React server components, which somehow create a hole in the client where the server renders something and then the client doesn't see what the server did. It's basically in the browser. It's a hole which the browser has no idea what's happening in there. And then like there's even more modern frameworks there like Astro.js or Quick, which stop this freezing of the state, but try to stream the state to the client, where the client picks it up and tries to figure out what the server just did. Sounds complicated. It probably also really is. And going back to what we actually wanted, and that was server-side rendering, it feels we're overdoing it a little bit. Found this on the internet the other day. I thought it was funny. So we're doing server-side rendering in the most difficult imaginable way possible. And now, cutting to the chase, I want to look at how we could do things better and make it faster and have some sort of way of generating HTML on the server, but still preserving good stuff on the client. So what we want is we want to have a really fast server-side rendering. So we're going to call lots of APIs. So we want something that's not blocking. So PHP, problematic because you can only do one call at a time unless you do some crazy hacks. Then another thing which I thought was working really well in React was the functional style components. So you have a component, you stuff props into it, you have these props typed in TypeScript, so you know exactly what data you're stuffing into them, so you see if you do something wrong. I thought this is something that React got really well, and also these components are quite lightweight and quite reusable if you compare them, for example, to Angular, where a component is like a really big complex thing, and React is quite lightweight. And the third thing, which I think is quite cool in React, is the context. So if you think about it, there might be a lot of components that want to access the user, for example, because I want to show a username or something. I want to avoid having to pass the user completely from the top of the hierarchy down to the lowest components. And React has this thing called context. And that's something I want to have on the server too. So my component can reach out and say, hey, get me the current user and deal with it without having to pass the user everywhere around. Client side, it's quite straightforward. I want thing to feel like a single page app. So there should be no flashes and white content. There should be a smooth transition between pages. And what I also want is to have easy, complex UX states, such as modals, drawers. So it feels like a modern application, not just like a bunch of documents stitched together. Before we continue, there's a short advertising break. Sorry about that, but just to get you the picture of what we're trying to do here. eTribes, we're currently working on a framework called Velocity. It's not a framework, it's a platform, really. So essentially what it is, it's two parts. It's an abstraction layer for speaking to commerce and CMS APIs, and it's a front end. And here we talk about the front end, but just to get the idea, the front end doesn't know who it's speaking to. So there's some sort of a contract which says, hey, load me a product. And then there is these connectors which then load a product from commerce tools. And if I want to switch to Shopify, for example, I would just change the connector, but the front end wouldn't notice this because there's this abstraction between. And what you're going to see in the demo later on is this kind of setup. So as I said, we have the storefront on the right-hand side. That's the front end. The front end only knows how to speak to a contract. And then there is these connectors that allow you to do different operations. And this is actually where this composable part comes in again, because I can pick and match which APIs I want to call. So I can say, hey, please do the cart from Shopify, but the Shopify search is really bad. I want to use Algolia instead. So you would say, okay, but the search contract, please send that to Algolia instead. So I can mix and match these connectors. We have Storyblock as CMS and Qdrin for AI recommendation system. We might have time to look at that later if you're interested. Okay, and anyways, the front end just loads the data and renders it. What I want to suggest for the server side. Thinking about it, what can we do to get really fast rendering? So first of all, I would suggest using Node.js. It's fast enough for most of the use cases that you want to do. I know it only supports a single core, but with that core, you can do a lot, and scaling to multiple cores these days is easy with Kubernetes and hyperscalers. The router, it doesn't really matter. We used Fastify because it's fast, but there's probably other solutions there. You could use Express or whatever. It's essentially all you have to do is you got to parse the URL that's coming in, figure out what should happen with that URL. So it's quite straightforward. JSX, as I said, you want to use that on the server too. We thought it's probably not the best idea to use the React JSX implementation because that thing was intended to run on the browser. So if you look at it, if you have JSX and it looks like HTML, but actually what it does is document create element diff, document create element li. So it essentially creates these DOM elements with JavaScript. But if you do that on the server, it's actually not necessary because then all you need to do is essentially string concatenation because you don't need to create the DOM. You just need to have a string concatenated, which is a flattened representation of the structure you're creating in JSX. So we're using a library called NanoWeb there. It has a small JSX implementation. I think it's 80 lines of code, straightforward, and it's silly fast, really. Context exists in Node.js and also, fortunately, now in quite a number of other runtimes, such as the web workers with Cloudflare. There's a thing called async local storage. And it's that. So it's exactly what the context is. You attach it to a request, and then inside the request down the road, you can access it and pull stuff out of it. It's pretty straightforward. Yeah, TypeScript, no biggie here. It helps to have the code safe and multiple people working on the same thing. So is this fast? We did some benchmarks, and we're actually quite happy with the outcome. So as I said, we have velocity speaking to Algolia, which is the blue line here, and then we have velocity speaking to Shopify. All of these tests are not cached, so it's really the pure calling. So the response times also depend a lot on the APIs we are calling, so Shopify, Algolia. And then we did the same thing with NextJS, and we are loading the data via our velocity backend implementation, but then using NextJS to render everything. Same thing with Shopify. And then just for the fun of it, NextJS has a commerce framework, which is a storefront that Vercel, so the guys who produce Next, did. And they have that, and it also goes against Shopify, and we ran it. And yeah, we could show that the performance of velocity is about 4 to 5 times better than any Next.js application would be. So as you can see, at a peak of 10 concurrent requests, we're going up to roughly, this is like 50 milliseconds, while as the other frameworks really go up high. And looking at the same data from another angle, the number of concurrent requests you can do with this per second. So because our APIs or our server responds much faster, then you can answer more requests in a second. And so you can see here, we clock in at about 180, 75 requests per second that you can handle with a single node instance. And that's actually quite a lot. So in this case, you don't even need caching really, because it's fast enough to handle quite a significant amount of traffic with that technology. Now, how do we get the nice front end? Of course, that's something we are all keen on. It should look cool and should feel good. We are suggesting to use a framework which is called Hotwire. So Hotwire is, in a nutshell, means HTML over the wire. Quick words before I continue talking. This is not a new JavaScript library that I'm shilling to you because, it's a new JavaScript library. This thing has been around for roughly 12 years now. It started shipping with Ruby 3, I think. It was called Turbo Pages back then. And they extracted it into a separate product. And now it's a standalone product, so you can use it wherever you want. Essentially, you load the package in the browser. It's about 50 kilobytes of JavaScript, I think. And it does a couple of things then in the browser. The first thing, and you can try this in any page that you have, it's quite easy to have this, would be that when you have a page and you click on something, that this framework intercepts the click, turns the operation into a XHR call in the background, takes the response from the server, so the server gives you full back HTML back, and then it does a delta update with what's on the page. And this is actually quite fast. And the difference with React really is that you don't load data from the server and then turn that data into HTML, and then you check what has changed with the virtual DOM. But what you do here is essentially render everything on the server and then throw it to the client and have it diff there. The diffing itself takes about 5 to 10 milliseconds, so it's fast enough for most of the stuff we're doing. And all of a sudden, your page feels like a single page app because you don't have these white flashes anymore. And if you want to look for this is actually used by quite a number of large pages, and you can recognize it quite easily if they're using Hotwire. For example, GitHub, if you click on something, you're going to notice this bar on top of the page going from the left to the right. Whenever you see that, that's Hotwire working. So they do that, they intercept at the call, they do it in the background, then they update the DOM. A couple of other features that they have, which are quite cool. This other one is called Turbo Frames. So if you still know iframes, it's pretty much a similar concept. So I can slice my page into different frames, and I can feed these frames with HTML fragments coming from somewhere else. So you could use that, for example, if you want a different team to be in charge of the navigation, then you would say, hey, I have this iframe, please call this URL to load me the header fragment. And then Turbo would inject that in there, just as an example. Or you could use it for personalization, where you want that certain stuff is really user-specific here. And the last part, and this is like the most complex thing, but also the most powerful one, Turbo has the concept of the server sends back with a stream tag, and then this would allow me to update individual documents of parts of the document. So you could say, for example, I do a post operation against the server, and the response is a couple of Turbo streams, which say, please update the cart counter and put a 1 there because I put something in the cart, but also update the cart button and turn it to a different color, something like that. So it's quite easy to do that, and it's partial updates. And if you know this sort of thing from the past where this exploded in your face because you started sending jQuery with it, with the responses, that's not possible anymore. You can only send HTML updates with it. So they restricted that. And you could even get these updates with WebSockets or server-sent events. So you could have a chat application that just pushes changes to the client and updates what the client sees there. So it works quite nice. Quick interlude here. You might be aware of ThoughtWorks. ThoughtWorks is, I guess, the biggest tech consultancy in the world. And in their technology radar 27, they said something that I thought was pretty interesting. And they said, SPA by default, put on hold. So that essentially means don't do it. And in a nutshell, they're saying if people are building front ends these days, they're going for single page apps because that's what they're used to. And they're like React developers and not JavaScript developers. And this is problematic because, of course, SPAs come with quite a technical overhead. And people should be looking at different alternatives like Hotwire. And it's quite interesting. They really explicitly put the name in here because normally they don't advise on individual technologies, but they felt that this is something that people should try. So it's not just my personal opinion that you should try this, but it's actually also some other people who find this pretty cool. Okay, then next thing. This is the most complicated. I hope I can get this right explained. Web components. So this is something that browsers all support out of the box now. And what they are is I can define my own custom elements. So Flow's web component would be a tag. So I have a greater than Flow component, less than tag with a closing tag. And what it means in the browser is that starting from that web component, there is a hole in the document. And under there, you have a thing called a shadow DOM, which is a completely new document with doesn't have any CSS in it, which also doesn't have any access to the outer world, and vice versa. The outer world cannot influence anything that's happening in there. So it's a really detached page in a page. And the way we're using them here is mostly we're going to handle state with them. I talked about that in a second. The fun part is when you use this together with Hotwire, is that as long as the new page that you send over the wire and Hotwire swaps it, as long as the new page still contains that web component, the inner workings of the component will be untouched. So you can replace the page, but what you put in the web component before stays. And this allows you to have like a flyout or a drawer where you reload the page in the background, but that web component stays as it is. And it works very painless, the whole thing. And then the last thing is slots. So that means I can inject something into my web component, which will keep the styling of the parent, so it will not be wiped out. And the web component will take what I pass in and put it in a place where I want it to be. And to make this more clear how this would look like, for example, if I wanted to have like a drawer on the right-hand side that comes out and shows me the menu, how this would look like is that I have this my web component thingy here. And in the web component, I put my whole navigation thing, nav, whatever, and observe the slot nav bar here. And what this does is when the web component then renders in the browser is that the web component has some dummy HTML element, which is the drawer and a button to close the whole thing. And then there's the slot with the ID navbar. And the browser will take this thing from here and inject it here. So essentially what the web component is doing essentially is just keeping state of, am I open, am I close? If you're open, then please show the whole thing. And if I'm closing, then please hide it. And this is pretty much what you would do in React with a lot more overhead with useState, useEffect, usehooks, whatnot. And in this case, actually, the web component itself is probably just like, I don't know, 20 lines of JavaScript because it's quite straightforward to do that. And the cool thing also is that if you reload the page because the user clicks on something, you would inject a new navbar in here. So if the navbar changes, because menus go away, you come to it, the web component is updated. So this is reflected. I'll show you to this in a second. It's actually quite mind-boggling to see it and how simple it is. All right, looking at what we have. So server-side rendering with secret sort, as we said, we're going to call these APIs and extract data from them. We render everything on the server. We throw everything as HTML, plain old, to the browser. Then we load this Hotwire thingy. And then what happens is that every subsequent call in the browser would be rendered as a new HTML page. And then the browser replaces everything. Simple enough, right? And I'm going to show this to you. We still have some time, which is great. So first of all, I share the URL. If you want to play around with it, please play with it. Give me feedback. So this is the thing. It's Tailwind styles. It's quite straightforward yet. So what we can say, It's a fast page. I mean, you can try to break it or try to see how fast it is. I have some metrics here. This is the page speed that the thing gets on mobile and the page speed score. So we get a straight 100. Just for comparison, some other systems out there. This is a modern Vue.js-based front-end framework that About You has pitched. And it gets a 70, which is pretty good still, but still quite a far shot. This is the default front end that Shopify has. So you're down to 28. And then if you want to do the same thing with Angular, this is Spartacus, the SAP framework. So they're at this level. So I think it's fair to say we are quite fast. Looking at some other features, for example, this is something I wanted to show. Let's check the bundle size. So you see here on a category page, caching is disabled. Let's try this again. So on a category page, we have a JavaScript size of 58 kilobytes compressed. So it's nothing really, because all we're loading essentially is Hotwire and then some extra stuff, which is the web components. To show you the web components in action, and this is something quite nice, I'm gonna turn this into a mobile navigation. So you see here, when I click here, this is what I talked about. This is this drawer. How it looks is that in the web component, we're rendering filter and the X button. And the rest of the stuff you're seeing here, this is a slot that was injected by the server. So once I click here, you can see that the page loads in the background and Turbo does its thing. But the web component keeps the state of, hey, I'm actually visible right now. And it updates also the navs that I'm passing in. All right, so it works quite nice. Some other things I want to show you, like the more advanced cases, but I thought they were pretty cool. And we have 3 more minutes. What we have here on this page is we have a tracking in place, which runs in the browser. So in the browser, I'm checking what the user is doing, and I'm collecting preferences for the user. I can see this if I hit the I button here. So you can see here that I visited products mostly in this size, and that at the moment, floral is my favorite color with 27 hits, and black is 25, and which brands I looked at, which categories, etc. So it's quite straightforward. And you can see here the floral dress is surprisingly at the top of the page. And if you're fast enough on the server, what you can do is, then I'm going to let this black product and load it a couple of times. And now if I hit I again, then you would see that now black has overtaken floral. And when I go to a category now, oh, wait, sorry, that's the wrong one. Then you're going to see, whoops, we have personalization. The page has dynamically adapted its rendering to prefer black products. I mean, it's a bit blunt. You probably wouldn't use colors, but more sophisticated metrics like sizes or brand preferences, whatever. But with the colors, of course, it's quite visible. And if you want to do this in a React app, good luck. It's quite tricky because we do everything on the server. The client sends the preferred color to the server with the request, and then the server says, oh, I got to boost black products because the user probably likes those better. We got that. So it's quite cool, this feature. Algolia is most of the logic behind it, but getting this to play right in the front end is nice. And then as a last thing, and then we're out of time, I guess, is, of course, we will have a ChatGPT-based plugin. It's not really necessary to do this. But what is fashionable in Hamburg these days? Okay. And what I'm doing here is we are sending this to ChatGPT. ChatGPT reasons about, does a couple of Google calls to look stuff up, and then it responds with a sentence. And then we are taking this sentence to do a query against our products, this time with a vector store. This was the Qgen thing that you saw before. And what this now does is, okay, Hamburg is hats now these days. That's interesting. What do I know about fashion? I have no idea. To wear in Italy. I don't know, you try that. So, and there's a broken image here, as you can see. So, yeah, it's a nice side effect. Just wanted to show you this because it shows basically the composability of a framework, because I can route traffic to different sources and different APIs in the front end without the front end having to think about who am I speaking to, because what comes out of the contract is always the same. So the front end doesn't see a difference which API gave you this data. All right, that's pretty much it. Hang on. What we got here? All right, so closing words. Yeah, right, that's the URL. If you want to have a look at it, feel free to test drive it and see what you think of it. We find it's pretty cool. And my recommendations for the whole thing would be try to see yourself as engineers. And all of you are probably not React engineers or Vue.js engineers, but in matter of fact, we are JavaScript developers or TypeScript developers. And I feel that it makes sense to look at the technologies out there and not just blindly take whatever frameworks being touted as that's the thing you got to do these days. Because I feel with a lot of use cases, you're actually much better off with something more lightweight than Next.js or Angular, whatever. And that the technology out there is actually very simple to have. And if you invest some time in it, I think the performance and the speed in development that you will gain actually will be much, much better than anything that you can get if you get it from the shelf. So be open to the solutions, play around with stuff, try to break things, and you're going to have fun working instead of just fighting Angular or Next.js all of the time. All right, that was it. Thank you very much. Any questions?